Hello everyone, it's me Atipan and you're watching Ati's repository. In the previous video, we were talking about self-attention mechanism and we were discussing several technical aspects of it. To be honest, those things are not particular to Chat GPT. It is kind of forming a basic foundation for the current AI that you are seeing right now. Irrespective of whatever field that you are working right now, AI is going to play a major role in it. It is good to know what is happening behind the scenes at some point so that you will be able to cope up with the trend accordingly. So with that intention, I have made this video with less theory and more visuals so that it will not bore you much. Okay, let's quickly get in the video. We know ChatGPT understands only the numbers, which we basically called it as a tensor. So which basically looks like an array of integers. So let's have some clarity on it. If you ask ChatGPT what is mouse, there is a possibility that it confuses whether we are asking about the device or rats. Because ChatGPT is trained with a huge data set, which includes both the device and cute little rodent. If your query involves the sentences related to computer, then the attention goes towards the input device. And similarly, if you are talking about something related to animals, then the attention shifts accordingly. This is because when we see a sentence, we look at each and individual words and we try to understand the meaning of the sentence. But ChatGPT doesn't do it. It sees the whole sentence as a single array of integers. Let's take an imaginary scenario. What could have happened when we queried about mouse? So ChatGPT takes the user input and convert it into tensor and then put it into some equation. Let's say if the result of the equation falls under some certain range, for example, let's say if it is between the range 0 to 5, the model may consider mouse as an input device. And if the value is greater than 5, then it consider mouse as an rodent. Again, it's just an imaginary condition. However, in reality, it may not be this much simple, but the idea is pretty much same. So in this video, we are going to do the same. We are going to take the user input and convert it into an tensor, put it into an equation, and finally, we are going to generate a response. Hope you understand what is the role of these integers. I have modified my code here, just imported neural network from Torch library, which is what we are going to use for implementing self-attention. You can see each words are already tokenized, which we have already done it in previous video itself. Firstly, let's create a self-attention class. In this class, we are going to have two functions. First one is like initialization, so where all the initializations takes place. And second one is forward class, where we define how it actually works. As we discussed in the previous video, we need to derive the value vector, key vector, and the query vector from these embeddings. Embeddings are nothing but different attributes used to define each and individual words in the sentence. So you can see the embed size is 2 here. Usually we have like 512 or 256 embedding size, but here we simplified it to 2. If we increase the size of the embeddings, it helps the model to understand the each and individual tokens more. So end of the day, all these tokens are converted into value vector, query vector, and key vector. Let's try to understand what these vectors are with a simple example. If you're searching for anything in YouTube, the query vector contains informations that are related to the text that you used while searching. And key vector holds information about video description or video title or something like that. And the value vector holds information about the actual value itself, that is the YouTube video itself. So hope you understand what those vectors are. As you can see here, we are getting the embeddings as an input, and firstly we are calculating the lengths of the embeddings. we are not going to write any logics to obtain these values. So there is an inbuilt function in neural network that is available in torch library itself. So using that, we can give the input as embeddings, and we can get output as those vectors. So basically we have converted this equation in code level using this Einstein summation. End of the day, we are getting this FC output, which is going to tell what words are like most probable words that can come next to the input embeddings. Now we are going to implement the sentence generator class. So this class is responsible for generating the response from user input. As usual, we need a initialization function. You know, the embeddings, attention, the FC output, that is a fully connected layer output. The maximum length is for specifying the length of the response. We are sending those embeddings to the self attention class, and there we are receiving it as a value, query, and key vectors. So firstly, let's fetch the user input and convert it into tokens. So basically we are going to send the input as tensors. So after converting to tensors, we need to call the self attention class. This logics variable will hold the output from the self attention class, that is the FC, fully connected layer output, and those scores are pretty much raw, which is not suitable to get at top probabilities. So we are applying softmax, which converts the raw score into meaningful probabilities, and that will be saved in this props variable. And we are going to randomly pick one top most probable word from the list, and we are going to return it in this function. Okay, now the function is completed. Let's add the chat bot with this function, and let's see if we are able to generate the response using this function. Okay, we are facing some issues. Let's fix them. Okay. Okay, it is working now. So if we give one word, it is just predicting the next word. Let me print the most probable words list so that you can understand more. So here you can see, if we give them, these are all like most probable words that can come after the word the. We haven't introduced any training method till now. Then how come it is generating the response? Let's try to understand what is going on inside. Let me print out all the individual variables so that we can see what is actually happening here. Now you can see the seed token the is converted into 20, that is made as tensor. You can see the embeddings that are actually converted into these vectors. The array has two integers because we specified the embed size as 2. If we convert it as 3, then the array will have 3 integers. But you know, usually we have lot more dimensions. As I said, we may have 512 dimensions for accurate results. And below that you can see logits. It is nothing but the response from the self attention class, and squeezing is nothing but removing the extra square brackets. The values and all, it will not change. And in probabilities tensor, we are just converting the scores into probabilities. And yeah, we are going to pick the top 3 most probable words from this list, and just randomly picking one word from the list for the sentence response. So yeah, without any training, how come this self attention class is giving us this logits? That's the question. After fetching embeddings, the self attention class tries to derive value vector, query vector, and key vector using the weights. Weights are nothing but the amount of information the model knows. Before training, the model doesn't know anything. So using those random weights, the model generates the value vector, query vector, and key vector. For better understanding, let's take an example. Let's consider a child is trying to recognize different animals. Initially, the child will not know anything, so the chances of correct recognition will be less. But later, we may teach about some common pets so that the child can recognize dogs or cats. At this point, even if the child sees a fox, it still claims it as a dog. So there is an error. The error difference that a child claiming dog to a fox is noted as certain value, which we can call it as a loss value. If the child says dog instead of fox, the error difference is smaller because it looks more or less similar. But the child says something like bicycle to a fox, then the loss will be more. So basically, if you teach more about fox and other animals, the loss will be reduced. Similarly, the weights or like the amount of information that a child knows. If you give more informations, the weight of the child will get updated so that the child can efficiently recognize things. The process of adjusting the weight is called optimization, and the process of calculating the error difference is called loss. I hope you understand what is optimization and what is loss. So basically, we are going to implement those things in our trainings so that instead of child, our model will try to recognize the next word efficiently. Okay, so below you can see the training pair, which is going to generate training data from our input data set. This is our input data set. So basically, we are going to create a sequence of input sentences and a sequence of target sentences. For example, if the input sequences is like the cat, the target sequence will be like the cat hates. And if this input sequence is like cat hates, and the target sequence will be the cat hates water. Let me print those tensors so that you can see the input sentences and target sequences. So these are the training tensors, and if we print the sentences, you may get a more clarity. Okay, here you can see the input and target sentences. So these sentences, these sequences are basically we are going to use it while training the model. Okay, let's implement the training function. So in this function, the model is going to predict the target word, and based on the loss, we are going to optimize the model further. Okay. The input tensors and the target tensors are fetched from the training pass function. And you can see the epoch. Epoch is nothing but the training unit. So if one epoch is completed, it means that one time the model reads all the input and training patches. The more the epoch, the more the corrections will be, and the more the model can predict without loss. For optimization and loss calculation, we are not going to write the logics and all. By default, there is a method for those things. So we are using Adam optimizer, which is the one that adjusts the weight of the model while correcting the mistakes. And the cross entropy function, it is going to calculate the error difference. So after training the model, it will become an expert at predicting the words. Now we have implemented the training function. You can see that we are just sending the input and the target pass batch by batch inside the for loop, and for every batch we are just calculating the loss function, and for every loss we are just optimizing on each batch. So I just printed the weights before and after optimize so that you can see what is happening in the training. You can see the weights are getting adjusted after each epoch, and for each input the embeddings value vector, key vector, and query vector are derived. And yeah, this is basically gives the weights of the model. You can see the loss values getting reduced after each epoch. Till now we are generating a response of only 2 words in it. Let's try to increase the length of our response. We can do it by simply looping the process of getting the next word. For example, if our user input is the cat and the model predicts the next word as hates, the sentence will be like the cat hates. And again, we are going to loop it, and this time the input will be the cat hate, and the model will predict the next word as something like water. So the cat hates water will be the sentence. So we can just loop it again and again until it reaches the maximum limit that we have specified. Okay, just need to include the for loop. It will run until it reaches the maximum length that we have specified. Let's make it 3 this time. So whenever the loop starts, we will fetch the input tensor from sentence. So initially the sentence will only have the seed index, and whenever the loop ends, we will append the next word in sentence, so that end of the day we will just return the sentence. Okay, the loop has ran for 2 times. As expected, we are getting 3 words in our response. So initially the input tensor has only 1 value, and for the second time the input tensor has 2 values. So this is working as expected. Okay, let's try to increase the length to 5, and let's see how it works. Okay, we are getting the response, but it is not like a proper response. Since our dataset has only like hundreds of words, which is very small for making a meaningful response, let's try to change the dataset and let's see how our model works. Okay, I have added several pages from Harry Potter and converted it as a dataset. Let me train it to the model using this dataset. Let's test the model. Okay, let's ask something. Okay, I like these responses. It is becoming decent. Let me ask something else. Oh, okay, these responses are getting better. You know, even when we update from hundreds of words to thousands of words, we can see the clear improvement here. Just think how it would be like if we train with billions of data set. This is exactly how Chat GPT works. The only thing is we are giving the seed word right away and asking to generate instead of asking it as a question. In our model, we use a very basic data set, and we haven't even implemented a proper encoding and decoding. We just mapped it to an integer and reversed it. So we use just 2 or 3 pages from Harry Potter. But in reality, ChatGPT is trained with a huge chunk of internet. Even with thousands of supercomputers, it takes like weeks and months to complete the training. Even after the training, there are still more processes to take place, like evaluation, fine tuning. Mainly, it should not provide a false data, and it should be ethically correct. I'm just telling, it's not only about the training part. I will not say this is how we need to implement the self-attention mechanism. There are lots of ways to amplify it significantly. The one that we have built is like a very basic skeleton. But yeah, I hope you may get a basic overview of what is actually happening in the backend. So that's the main intention of this video. So I hope this video is helpful for you. And this is the AI playlist. I'm going to make several videos about AI and machine learning. In the next video, let's try to see if we can generate an image using our local machine. So stay tuned for the upcoming videos. So once again, thanks for watching. So see you soon on the next video. Until then, take care. Bye bye.